Yes.
Yeah. Okay, so what we were doing in the last class, so we were doing the acceleration due to gravity, right? So let's wait for 1 or 2 minutes. Please do the revision of the acceleration due to gravity. So in this class, I'm going to derive the acceleration due to gravity formula, right? So this was the statement, oh, sorry, formula that was the G is equals to GM by R square, right? So, and also everyone, I was checking your weekly test. So there was a very simple question. The first question that says the force between the let me just a moment. Let me just a second. That was the first question of this paper, weekly test. Just a second. What was the force of attraction between two unit point masses separated by a distance is called. And I'm shocked that everyone, like nobody, not a single person marked the right answer. Everyone marked the wrong answer. And I know that some of the students have not given the test yet, but I'll not reveal the answer. Once you will basically give all, like once you all will give the test, then I will reveal it. Because that will be an advantage to the students, like they those who are going to give the test on Saturday, right? So I'm not gonna reveal it, right? So it's a request, everyone. Please do the basic revision. I'm shocked that little, like how is it possible that nobody did the nobody marked the right answer? Arhan, your video is not visible to me, Bache. I think you have, please check your camera. Okay, so please do the basic revisions, right? Okay, so, and also one more thing, everyone. In this chapter, calculation is very important. So if you cannot solve the questions properly, you are going to lose your marks, right? So it's a request, please, and please work on your calculations. Okay? Is that clear, all of you?
Okay, sir.
Chalo, that's great. Just a second. Let me ask whether some students are joining or not. Okay, so just a second. Is my screen visible to all of you?
Yes, sir.
Yes, sir.
Chalo, that's great. Take it. So just a second. Let me start the class. Is there anyone who is having exams right now in your schools?
I see. Me, sir.
Uh, okay, Rayan is having. Anyone else apart from Rayan? No one. Okay, sure. Bye bye. Take it. Okay, everyone. Let's start the class. Okay. So now let's derive the. So I'm going to write it here because this derivation is in your NCRT as well. It means that this is the portion of your school syllabus. If something is given in NCRT, rationalized NCRT content, it means that that is a part of your syllabus. It depends whether the school will ask or not, but this is a part. Is that clear, all of you? So please and please do not miss any word or any topic of the NCRT given in the book. Okay? So it depends on the school to school that some of the schools are not having the conservation of momentum topic, but still that is in NCRT. So by default we are going to cover it, but some of the schools are not having it, so students can basically just use this as a knowledge, right? So that's take it. So now let's understand the derivation portion. Derivations. So first of all, everyone, if a body is there of mass m, suppose stone or you can say ball or anything, the small m. Okay, so just a second. Let's take just a moment. Just write it calculations. Calculation of heat. Okay. So suppose that a body is dropped from a height h, right? If you suppose we have dropped a body of small mass m, okay? So we are assuming that suppose body of mass m from a distance r. So everyone, whenever you are going to derive any equation, you have to write all the things, that what variables you are taking, what is small m, what is r, capital R, what is capital M. So you have to define it first so that the teacher can understand, yeah, student knows this thing, and they're basically, they have explained whatever they are doing in the question, right everyone? Okay. From a distance r from the center of earth mass m. Okay. The capital M is the mass of earth. Okay. So the force exerted by the earth on the body, according to force of universal law of gravitation, would be, let me write it over here. Body just a second, everyone. Earth on the body is by, so that would be nothing but your F is equals to G capital M by R square. Is that clear? Yes or no? The product of the masses and the distance between them. Is that clear, everyone?
Yes, sir.
That's great. Okay, everyone, please do let me know that the force exerted by the earth produces an acceleration as well. If this is force exerting on the body, so that will also produce the acceleration if if external force is acting on it. So there would be some acceleration, yes or no, everyone?
Yes, sir.
Right? Or in other words, you can say that the mass, okay? So not mass, sorry, weight of that, you can say the body that is falling from a height h. So G will be acting on it, and M is the mass. So weight would be M into G. Yes or no? So both are forces. Weight is also in force, is also a force. So just a second. Let me write the equation first over here. Right. the weight mass m is, so weight is nothing but a force, or you can say in terms of the force that is produced by the acceleration due to gravity, right? Because earth is exerting source of force, and the force would be, is that clear to all of you? So as you can see, both are forces. So can I equate both forces, yes or no? Equation 1 and equation 2.
Yes, sir.
Okay. So I'm going to equate equation 1 and 2. So from into that mg would be equals to, sorry, g mm by r square. Okay. As we can see, mass will get cancelled. So the left is g is equals to capital G, capital M, and r square. Okay. So this is how we prove this thing. Is that clear to all of you? Please do let me know, everyone.
Yes, sir.
Any doubt so far, 21? Yes, Bharti, you were saying something?
So the capital G is the gravitational constant, right?
Yes, capital G is the gravitational constant. Yes.
And capital M is the mass of the Earth.
Mass of Earth. Yeah.
Okay.
This is how you can derive this equation. Right, everyone?
Okay, sir.
So and we have already discussed that the gravity acceleration due to gravity is not constant all over, like it depends on the mass of the body, right? And the radius or the distance, you can say. Any doubt so far to anyone?
No,
Just a
sir.
second. Just a second, let me check. I did written, I have written something there. So, this was the question. That's what I was thinking. So would you like to try this question, everyone? We just have to substitute the value. Just try it in the formula and calculate the value of G on the moon. Please try this question, everyone. I'll explain if you're not able to solve it. The answer? Anand, how are you, Bache? Anand, am I audible? It
Yes,
seems like
sir.
Hanan. No, Ryan, not you. Hanan.
Yes, sir.
How are you?
Good, sir. How are you?
I'm good. How was your exam?
It was good, sir.
Was good? Okay, that's great. Okay, Afrin, also got your own answer sheet and you scored very, very well. That was good. 78 out of 80 is a very good number. Afrin, am I audible? Am I audible?
Yes, sir.
Yeah, I'm saying that you have scored very well. The marks are very good. Okay, so please do it and let me know. Hanan, when you will get the marks?
Not sure, sir. They have not said the date yet.
Okay, chalo, okay, bye. No issues. Any answer by anyone?
I
Please do
think
let me know.
gravity 1.63 meter per second square.
6 point?
1.63
Okay, 1.63 meter per second. Square or meter per second?
meter per second square.
Meter per second square. Chalo, that's great. Chicken. Anyone apart from Afrin? Okay, Bharti. Okay, everyone, let's do it together. Question is saying that mass of the moon is given to you and the radius of the moon is given to you, and the value of capital G universal gravitational constant is not going to change at all wherever you go in the universe, right? That's why the name given to you, the name given to G, capital G, is universal gravitational constant, right? So we have to calculate the acceleration due to gravity on the moon. Okay. Now let's calculate it. Let's write down the things. First of all, the mass of the moon is 7.4 into 10 to the power 22 kg. Radius of the moon is 1740 kilometers. So kilometer is not the SI unit, so we have to change it, this thing, right? So that would be 740 into 10 to the power 3 meter. So what can I do is that I will basically, I can write this thing 1.740 into 10 to the power 6, yes or no, everyone? Right? And the value of G is already given to you, that is 6.7 into 10 to the power minus 11 Newton meter square kg square. Okay? Now, simply, the formula is given to you, that is G is equals to Gm by R square. Now, substitute the values over here, 6.7 minus 11. Okay? Just a second. Into mass is 7.4 into 10 to the power 22 divided by R square. That is 1.74 into 10 to the power 6 square. Okay. So that is coming out to be, as you can see, this is 12. So this will become 6.7 into 10 to the power. Instead of that, let me write 7.4. 22 positive, 11 negative. So positive of 11 will be left because the base are same according to the law of exponent, divided by 1.74. So I can write 1.74 into 1.74 into 10 to the power 6. It is 12. Okay. So now, as you can see this thing, everyone, that it will go in the numerator, that is negative 12 and positive 11. Negative of 1 will be left in the power of 10. So that would be 6.7 into 7.4 into 10 to the power 11 minus 12. Okay. Divided by 1.74 into 1.7. Okay. So now this value comes out to be 1.63 meter per second square. That is equals to 1.63 meter per second square. Okay. So the value of G at moon is 1.63 meter per second square. Okay. So this is the value of the gravitation acceleration due to gravity on the moon. Clear, everyone?
Yes.
Any doubts so far to anyone? Please do let me everyone get out so far. So, as per the calculations, this unit, this value of G as compared to Earth is 1 by 6 time of the moon. Okay. So here it is written that okay, so this is one of the most important topic of the gravitation. Okay, everyone. The acceleration due to gravity and the equations of free falling motion. The okay, so we are so please and please revise from now onwards of this chapter. Okay. And it's a request to all of you. Please do the revision of equations of motion for the next class, because in the next class we are going to start the equation of motion for free falling bodies numericals. Okay. Because the numericals will be of same type. Only the difference would be, instead of acceleration, we will be using acceleration due to gravity, and high instead of displacement, we are going to use height. Clear, all of you?
Yes.
The value, not small value of G of the Earth on the Earth. Okay, that's great. So this is the thing. Now the next topic that we are going to start is the equation of motion for freely falling bodies. Okay. So this is one of the most important topic in the gravitation. So in the first column, we are going to discuss about the general, let's say, linear motion. Because there is a straight line now. Whenever we do the whenever we talk about the normal motion, that is a straight line motion. And this is free falling motion. Okay. Now, one by one, please do let me know the values, not the values, sorry, the equations of the motion. Please do let me know. Let me know the what were the equations of motion that we have studied in the class of motion.
V equals to velocity.
One by one, one by one, one by one. Okay, Rayhan was saying something. Then Arhan, you can speak.
V is equal to U plus AT.
Okay, first equation. Second, Arhan.
S equals to UT plus half UT square.
Okay, that's great. What about and the third equation? What was that?
V square is equal to U square plus 2S.
Okay, Rayhan. Yeah, that's correct. So V square minus U square is equals to 2AS. Okay, so these were the three equations, right, everyone? So in this chapter, we are going to replace and we are going to modify a little bit. The the normal equations, we are going to modify a little bit according to the gravitational you can say motion. Okay. So now let's just a second. Actually, my pen got stuck. Just a moment. Okay, so let me write the first equation. That was the V equals to u plus at. Okay. Second is S is equals to ut plus half at square. ठीक है. Third is v square minus u square is equals to 2as. ठीक है. So these were the three equations of motion. Yes or no, everyone?
Yes, sir.
चलो, that's good. ठीक है. Now let's modify this thing for the free fall motion. The first equation will be the velocities will remain same, only the acceleration will be replaced by the acceleration due to gravity. Is that clear to all of you? Please do let me know. The second equation will be modified. Instead of S, we are going to use H, that is height, because we are talking about the vertical motion. It could be downwards or it could be upwards, right? So H is equals to ut plus half gt square. Third equation would be v square minus u square is equals to 2gh. Okay, so this is the thing. Any doubt so far to anyone?
No, sir.
Sure. Sure, that's great. Okay. So let's write something about this topic. Then the next would be the numericals based on these. Let's see whether we can start the numerical portion in the class itself or not. Okay. Okay. So now in this class, we are going to talk about a little bit sign convention of this. Okay. So sign convention is basically, so these are some general points when we are talking about the free fall motion. So everyone, when the body is falling vertically downwards, so its velocity is kept increasing. Yes or no, everyone? The velocity,
Yes,
when you
sir.
drop a ball, the velocity will continuously increase. So in that case, the body is performing accelerating motion, the uniformly accelerated motion, right? Is that clear? So in that case, G is taken as positive because the body is basically increasing the velocity, right? So any doubt so far?
No, sir.
That's great. Let me write it over here. Sorry, just a second. I don't know, my pen is a little bit creating a lot of problem. So when a body falling vertically downwards, its velocity increasing. So the acceleration due to gravity that is usually is taken as positive. So these are sign conventions. When we will be doing the numericals, we will be considering these signs as well. Okay. So it's a request to all of you, please and please revise. Okay. The next is when a body is thrown vertically upwards. So the value in that case, the velocity will be kept decreasing. Why?
Because it is going upward.
Because the ball is going upwards, so the velocity is continuously decreasing. At the highest point, the velocity will become zero. Right, everyone?
Yes, sir.
That's the thing. Okay. So whenever the ball is going upwards, so that motion will be deaccelerating. Clear, everyone?
Yes, sir.
Sure. So it's velocity. So that's why it's a request again. Please and please revise for the next class, because this is all about the sign convention. If you okay, if you change the sign, so the answer is going to be different. Yes, Jasola. Due to gravity. negative. ठीक है. Next case. So when the body is falling downwards, so in that case, the initial velocity will be 0. Right, everyone?
Yes, sir.
Because you are just dropping the body. There is no external, you can say, push or pull to the ball or body. Right? So initial velocity of the body would be 0 when the body is dropped freely. Okay? Dropped freely. Height, from a height. So its initial velocity would be 0. Okay? There's no any doubt so far to anyone, please do let me know. And when a body is thrown upwards, so in that case, the final velocity will be 0, because in that case, that would be a deaccelerating motion, and the body will keep decreasing the velocity. So that's why the final height, the maximum height at that point, the final velocity of a body would be 0. Is that clear?
Yes, sir.
There, everyone. And next thing, that is a very important thing. That is the last portion. That says when a body is thrown upwards, so the time taken by the body to reach the highest point will be equal when the body will fall from the same point to the point from which it is thrown. It means that if you're thrown a body, if you are basically, suppose that this is the point of projection, it means that you have thrown a body in the upwards. So at this point, the body has taken 2 seconds. So the body will take another 2 seconds to reach the ground as well. Okay. So the time to reach the maximum height will be equal to time to fall from that height. Is that clear?
Yes, sir.
That's great. So to rise. Is equal. Time it takes to fall from the same height. That's clear to all of you? Any doubt so far to anyone? Please do let me know.
No, sir.
Sure, that's just a second. So, do you have buoyancy and Archimedes principle, बच्चों?
Yes, sir.
ठीक है. Okay, so the theory part of this portion is covered. So in the next class, we are going to start the equations of motion for the freely falling bodies, numericals, right? So from now onwards, only two topics are left. Majorly two topics. Thrust and pressure is not that much, you can say, big topic. Only the main topics are mass and weight and the, you can say, the Archimedes principle and buoyancy, right? So in the next class, we are going to continue that. Why did everybody left the class? It's only just a second. Anan, Bharti, and Rayan in after input. What about the rest of the students? Okay. So from now, everyone, please do share your question papers after your exams. Okay. How many of you have sent the question paper on the official number? After, okay. Bharti, did you? Okay, that's great. Thumbs up. आज कुछ तूफानी करते हैं. Chalo, that's great. What? Okay, Rayan is having exam. Hanan, did you send the question paper?
Sir, I'll set it.
Okay, please send it. And Bharti, have you got the answer sheet from
I
your
am.
schools?
No, sir.
No. Yes, Rayan, you said something?
I am also having the question paper.
Okay, okay. So also, Rayan, you can send it. I thought that you are like you didn't give the exam right now, so that's why I didn't ask. Okay, no issues. So you can also send Rayan. We'll discuss that question paper as well. Afrin, please send your question paper as well, okay? And okay, so Rayan is having and Afrin. Okay, check it. And one more thing, everyone. If I think if it's possible, so please also make a PDF of your answer sheet, midterm answer sheet, and send it on the official number so that I can analyze and we'll discuss what mistakes you have made in the question in the answers, and where there is a requirement